I'm Willis, and with me, Wason. We're here to introduce wireless broadband data analysis in California, a multi-institutional collaborative project funded by the California Public Utilities Commission. The California Public Utilities Commission is conducting quarterly field tests across 1,200 locations in California. For these field tests, two network analysis tools were used, Iperf and Glasnost, which were used to collect data. These tools collect data regarding TCP transmission and network flow. At every location, 4 service providers were subjected to 4 upload and 4 download tests, each test consisting a minimum of 10 data points. This equates to a minimum 384,000 data points per field test. The California Public Utilities Commission has identified that there is a fundamental problem regarding the service provided by wireless broadband companies. Due to this, the field testing was conducted to analyze the actual service provided by these companies. The quantity of data collected from these field tests is not easily interpreted by humans. This makes it difficult to produce meaningful conclusions about the data. To emphasize how difficult this data is to interpret, we've included a sample data test file. As you can see, it's not readable, much less can we make any conclusions based on it.
So the solutions that we came up with was to create scripts. Scripts are basically just small programs that would automate the process of going through the vast amount of files that we had and grab the specific data that was needed to come up with actual answers with all this information. In addition, we wanted to be able to provide information to both the public and policymakers like the CPUC so that they could better understand how ISPs how they better manage their networks. Our methodology for this was to first start off by meeting up with our capstone advisor and then create questions that could be answered with all this information. After we had done that, we began the process of creating scripts using various programming languages. The next phase was to go ahead and start testing our scripts, making sure that they were proper. After we had first manually tested our scripts, we gave it over to other coders who could then verify their scripts work properly. And finally, once our scripts were pretty accurate, we went ahead and we created a graph to show off our results.
Upon processing the Iperf data with our post-processing scripts, we observed trends that lead us to conclusions about the service providers. We observed that upload streams are more susceptible to noise interference than download streams. This observation is present in all service providers. For download streams, AT&T, T-Mobile, and Verizon experience a right-skewed distribution of noise, which indicates that there's very little noise between the technology and the actual data that's being transmitted over these networks. Sprint is the exception, where we observe a normalized distribution with a median between 50 and 60%. These findings have been submitted for publication in the IEEE conference, GlobeCon 2013.
Glasnost is a network application that collects traffic shaping information. And what traffic shaping is basically the process of your internet service provider intentionally slowing down your internet speed. So say you're watching Netflix and you've been watching shows for a while and all of a sudden you notice your speed going really slow. It's possible that your ISP has intentionally slowed you down. And so the way that we determined traffic shaping was by comparing a stream flow and a control flow together. So in the image on the right-hand side, you'll see highlighted in red a stream flow that's 2,000 kilobytes per second and a control flow that's 4,000 kilobytes per second. That's a size difference of 50%, and so in that case, it's highly likely that traffic shaping occurred. In the bottom left graph, you can see the number of traffic shaping occurrences for a percent size difference. So at 10%, you see the highest occurrence of traffic shaping instances, and then towards 30%, we see no more instances of traffic shaping.
All right, a large quantity of tools were used in the development of this project. Among the most notable is the Iperf and Glasnost data, the BlueJ Java development environment, and Microsoft Excel.
Throughout our capstone project, we learned a whole lot of different things. We learned different programming languages. We also learned how to analyze data at a detailed level and come up with meaningful results from that data. And then also we learned a lot of soft skills like managing our project and time, working with all the different homework we have, school, friends, different things like making sure to still get our work done. And then we also learned about how to deal with different problems and risks that can be involved with a project this size. And of course, learning to communicate with each other to make sure that we get everything done properly and on time.
All right, thank you for your attentiveness during the presentation. It's much appreciated. If you have any questions or would like to learn more about the project, please visit